I am Dr. Jeff Bradstreet. I'm a medical doctor. I'm a homeopath, but only in the state of Arizona, where I practice infrequently these days. I am guest faculty at Southwest College of Naturopathic Medicine. I'm adjunct faculty at Western U. But my primary practice is in the Atlanta area. I do see patients also in Newport with the Brain Treatment Center there. We have a brain treatment center in Atlanta as well, where we're conducting the MRT research and treating kids using magnetic therapies, which we discussed earlier, but we're going to see some amazing results and hear from some parents tomorrow and today about the kind of things that can be integrated into the whole package. Do we lose Mike? Yeah. Is it back? Okay. They're just like playing a switch. On, off, on. Sounds like we're good right now. So the whole package is a combination of building a proper foundation, both nutritionally and restoring the gut ecosystem, which this talk will help you to kind of facilitate that process. But at the same time, we need restoration. We need restoration of neurotransmission, restoration of cognition, function, sleep, other things, and repairing and re-signaling the immune system. The immune system doesn't like to forget. When it gets its dials turned up to a pro-inflammatory state, that can be really challenging to undo that process without drugs. And we don't want to use drugs. We want to use things that actually speak to the underlying mechanisms without drugging those mechanisms wherever possible. So, this has to be true. How many of you are willing to give up on your kid? See? So there has to be some way. We got a lot of moms, a lot of thinking moms, a lot of working moms, a lot of revolting moms, not in that sense revolting, but revolutionary type of moms. That didn't seem to come out quite the way I intended it. I have learned so much. I feel like I have about 4,000 mothers. It's just amazing because you all tell me what to do pretty much every day. So this is only meant as a wow. This is a journal article, which is practically a textbook, looking at the pharmacological applications of the endocannabinoid system. And I'm just putting it up there to let you know that medical science is looking at this as kind of the undiscovered country. There's been a lot of work in many areas within the plant kingdom as a source of deriving new pharmaceuticals. This is an area, because of regulatory hassles, that has been really delayed. So it's kind of left out there as something new that could be exploited by big pharma. What I hope to show you is that nature has already provided the solutions, and I don't think big pharma is going to improve on them. They want to, because then they get proprietary drugs that you have to pay $4, $5, $6, $7, every day to take. But I think nature is already there for us, and I'll show you why. So, evidence of a common endocannabinoid-related pathomechanism in autism spectrum disorders. Wow, what a tongue twister. I'm going to explain, and we're going to go through a little glossary to define the endocannabinoid system. Just for fun, I sent an email out to about 20 colleagues. These are physicians. And I said, what do you know about the endocannabinoid system? What do you think the responses were? Nothing. They didn't know anything about it. They hadn't heard anything about it. It's not part of the standard dogma of medicine. So they are not informed at this point in time. And I was ignorant until a year ago when my Italian research collaborator said, hey, what do you think about exploring this? And I said, what? And then I had to go out and get educated. The good news is there's actually a tremendous amount of data already published. I'm going to show you a lot of articles, but there are hundreds. And I may at the end of this talk just kind of zip through about 100 slides real fast just so you can go like, wow, he's right, there are hundreds of slides. There's hundreds of articles out there on this system and brain inflammation and everything else. If you're not familiar with PubMed, it's a really simple process to go on PubMed. You can type in endocannabinoid system and whatever you want. Crohn's disease, psychoses, stereotypies, because it's helpful in that pathway. How many of you have kids that if they could just stop self-stimulation, like all the stereotypies, if they could just stop that, life would be so much better for them, and they would be so much more teachable. So I'm going to show you that that's entirely possible in 1 day of treatment. I know it's hard to live up to those kind of statements, but it's true. So back channel communication, and I know that with my pointer I can't point at both slides at the same time, so I'll do this. Back channel communication through the synapse of regulatory cells. These are basket cells that have been described to regulate pyramidal cells. This may be very similar, and I'll be interested to see what Professor Casanova thinks about this, because he's worked a lot with some of the supporting cells within the mini column. But this concept, these particular cells within the mini column, are regulated by the endocannabinoid system. So they regulate the dopaminergic pathways and the glutaminergic pathways through their regulatory effects. This is autism-associated neuroligand 3 mutations commonly disrupt tonic endocannabinoid signaling. So this is a well-described, fairly rare mutation that can be used as a model of autism, but it shows that the pathway of how all of this works to create the autistic phenotype is through the endocannabinoid system. So, would some cannabinoids ameliorate symptoms of autism? It's an interesting question. So cannabinoids come in a whole bunch of different varieties. And I'm not talking about, whether it's this type of weed or that type of weed. I'm talking about the nature of the specific chemical structure of the cannabinoid within the actual extracts. There are a minimum of 40 common, but probably 3 or 4 that are really the most active pharmacologically within the system. I would say the answer to this question is absolutely, and I'll show you some proof of that, or evidence if you prefer, in a little bit. We published this in July of last year in the Journal of Autism and Developmental Disorders. Cannabinoid receptor type 2, but not type 1, was upregulated in peripheral blood mononuclear cells from children affected with autism disorder, and we had a large control population. And that was a very interesting observation. That pattern is exactly what you see with chronic inflammation. It's what you see when you stimulate a laboratory animal with LPS, which is an endotoxin from bacteria, and it's part of the whole concept that chronic low-dose exposure to bacterial toxins actually stimulates this system in a pro-inflammatory way, resulting in, I think, autism, but obesity, cardiovascular disease, type 2 diabetes, and an increased risk of neurodegenerative disorders. All of that is tied into the same pathway. You need something, if you think about this for just a minute, you need something in autism that can explain these really bizarre observations that we all see. One Fruit Loop and the child's psycho for a day. 3 little goldfish crackers stolen from the therapy table and the child goes nuts. A visit to grandma's house, and I know there's a lot of grandmas here, God bless you all. A visit to grandma's house and a slip up with ice cream and the child is gone, just gone for days in just psychotic sort of, bewilderment and self-stimulatory behavior. How do you explain that? How do you explain the observations with what we see with the gut ecosystem? Is it truly just the chemical toxins and the chemical mixture from the gut ecosystem? Is it just the allergic reaction to yeast or bacteria that's causing this sort of thing? Is it interference with biochemical pathways? How do you get such profound sensitivity where like tiny little things push your kid all over the place? And to me, the only regulatory pathway that has that kind of power and that diversity of control over the human body is the endocannabinoid system. It's there, nature provided, to do a couple of very important things. Your brain has to know what your ecosystem is up to. That means your gut ecosystem, but the surroundings that you find yourself in. The food that you eat changes the regulatory pathways within the endocannabinoid system in your brain and your GI tract to adapt you to that diet, but also say, hey, I'm missing something here, and make cravings where you want to go out and eat this, that, or the other sort of thing. You ever notice how our kids have these crazy cravings? They have those kinds of cravings because it's driven through regulation of the endocannabinoid system, which is giving them this kind of, it looks like addiction to wheat, but you really can't explain it on the basis of glutamorphines and those kinds of compounds in wheat. It really looks like addiction to dairy, but you can't explain it on the casomorphines alone in dairy. So there's something else that's doing that, and the strongest system in the body to regulate that kind of addiction pathology would be the endocannabinoid system and its malregulation. We talked about this earlier. The fact that vitamin D binding protein, which is also GCMAF, can re-regulate the transcription message and change the way the cannabinoid receptors are being produced to regulate the inflammatory or the lack of inflammatory response in children. And macrophages are a key player in this. They behave a little bit differently than the monocytes do. So there's variations within the immune system and the cannabinoid dysregulation within different cell types within the immune system, which gets very complicated. Again, this is, in my opinion, this vitamin D binding protein, the activated form GCMAF, and the endocannabinoid system is the nexus of autism. It links the GI tract microbiome, which is hugely important, but the microbiome, I'll show you, primarily is doing its mischief through dysregulation of the endocannabinoid system. We saw a remarkable improvement in the dysfunction of these cells. I'm not going to go through what the different staining techniques make. You can download the article. If you need the article, I can give you the article. But it's big changes in the enzyme pathways that both break down and create these molecules for the body. And I'm going to define these for you in just a moment. So consequences of cannabinoid and monoaminergic system disruption in the mouse model of autism. And boy, they really nailed it with this. I mean, they're right on target. And they say this: our data provides a basis for further studies in evaluating the role of cannabinoid and monoaminergic systems in the etiology of ASDs, autism spectrum disorders, and whether this particular mouse model can be used both as a model of schizophrenia and autism. And there's huge overlaps between those. And there's an abundance of data on schizophrenia and cannabinoids and endocannabinoids. And we can start to extract on that as a basis to start talking about autism. There's only about 6 or 7 articles published on the endocannabinoid system in autism. That's about it. And 2 of them are ours. And we think that we're starting to get a handle on where this is headed, but that's not a lot of data yet. We're really at the early stages of starting to explore the system. So let's get the lingo down. Endocannabinoid system, which are the receptors, CB1, cannabinoid 1, cannabinoid 2, they work differently, and the ligands, which are fatty acids that plug into them. It's like when you go to plug your light into the socket. Okay, the ligands actually attach to that receptor. When they do, things start to happen on the inside of cells. They're fatty acid compounds. There's enzyme pathways that either build up those fatty acid compounds or break them down. That together is all part of the endocannabinoid system. And you can change the regulation through different sorts of means that addresses that. CB1 is primarily, not exclusively, but primarily the responsible agent for the psychotropic effects of cannabis. So when you see THC type of effects on behavior, mood, thinking, and delusions, depending on dose, that's related to the CB1 receptor. The CB1 receptor seems to have some very unusual properties. At very low doses of stimulation with THC, it's anxiolytic. You go past that dose a little bit, and it's paranoia-inducing. So there's a very small therapeutic window with THC. So a lot of caution with that kind of a compound. CB2, on the other hand, is non-psychoactive. It is responsible for the anti-inflammatory effects, and it's the kind of the countermeasure of CB1. So you have CB1, which is pro-inflammatory as well as psychotropic, and CB2, which is anti-inflammatory but not psychotropic. All right? CB1, inflammatory, psychotropic. CB2, anti-inflammatory. Ligands are those fatty acid substances. Anandamide, so anandamide, better known as AEA, and 2-acrodonoglycerol, which I would rather say 2-AG. Wow, it's a tough one. Those are kind of the crazy little fatty substances that are naturally occurring that help to bind to this, but there's other endocannabinoid lipids that do that. FAAH is the degrading enzyme that breaks it down, and they're looking at drugs that inhibit that enzyme pathway as potential therapeutic targets to improve endocannabinoid function. So if you block the enzyme that breaks it down, you might have a better effect. You know, when you start tinkering with Mother Nature that way, and you deliberately interfere with natural enzyme pathways as opposed to augmenting and helping and rebalancing, that's tricky and a dangerous place, because this is such a complex system. I think we need to go cautiously in medicine as we develop these new pharmaceutical agents. NAPE-PLD is the maker of this important compound AEA. Phytocannabinoids are plant-derived, and it's not just marijuana-derived. There's a lot of plants that create phytocannabinoids. Some of them are very weak. Marijuana tends to have some of the stronger related cannabinoids that are more active. THC is psychoactive. Be cautious with anything that delivers THC except in microdoses. Cannabidiol doesn't act. It's a very potent ingredient in the hemp oil extracts. It may be anywhere from 14 to 22%, depending on the product, of a hemp oil extract. But it has almost no activity with CB1 and CB2. Instead, it acts at the PPAR, which are regulators of DNA transcription, to change the message. So cannabidiol is very intriguing because it bypasses both CB1 and CB2 to kind of rewrite the message from the DNA out. Dietary cannabinoids, I'm not talking about going out and eating loco weed. Dietary cannabinoids are common. The most important one is beta-caryophyllene. Now I'm going to talk about that and what it may be important for shortly. It's a weird bicyclic compound that has this strange ring structure that gives it its unique property. It's actually really a rare chemical in nature. It's present in many essential oils. And how many of you are kind of thinking essential oils and working with essential oils and think it's kind of cool stuff? So it's present in a lot of essential oils, and it may be one of the most active ingredients in essential oils. So clove, hemp for sure has a lot of it. Rosemary has a bunch of it. Hops does, so all you beer drinkers should be happy about that. It is, by the way, the ingredient that drug dogs are trained to sniff out. That's what they're going for. It's a very strong aromatic compound. It's not psychoactive, has none of those kind of properties, but that's what their nose is going to cue in on. So you know what I think about taking hemp oil through airports, right? Exactly. Not a wise idea, especially in Thailand or other sorts of places. Having seen some of those movies, you don't want to wind up in the jail in Thailand. So. Piperine, also known as bioperin, is a fascinating compound. Its name is derived really from where we get the name for pepper, and it's an intriguing compound in black pepper, but other plants carry it as well. And it facilitates the uptake of pretty much all phytochemicals. So it's going to be a delivery mechanism, but it has its own action on BDNF, brain-derived neurotrophic factor, that I'm going to show you. But this is pretty remarkable stuff. There's an ancient bottle. This is back from about 100 years ago. This is from the Hemp Industry Association versus the DEA. And essentially, I'm not a lawyer and I haven't analyzed this case, and I'm not giving you legal advice, but the various people who are selling products here can give you some advice about that. It appears that because of the absence of psychotropic effects in hemp oil-related products, in 2004, the DEA just kind of backed off. And right now, we live in a regulatory state of confusion. And we have this state doing that, and that state doing this, and the DEA saying this, and the FDA saying that. It's chaos. It's really chaos at this point in time. However, it appears that there is an abatement of regulations related to this and enforcement of anything related to this. It's a little tricky because you can get the oil and the oil is okay, but you can't actually grow the plant to get the oil in most states. So you've got this little catch-22 going around. I do hope that this problem is resolved at the highest levels of government quickly, because this is too important of a chemical to leave in such kind of confusion in terms of what the regulations are. So this is just a slight little diversion for a moment to get off on imaging neuroinflammation. So if autism truly represents a neuroinflammatory disorder or activation of macrophages so that their chemistry is abnormal without typical inflammatory changes, just changing the state of a macrophage. So it's still there, it looks pretty much the same, but its chemistry has changed a little bit. Can we image that as a biomarker? Kind of cool. So this is the Parkinson literature, and the answer is yes. So you see all those kind of green dots? Those are areas of activated microglia in Parkinson, and you can see primarily limited to the corpus callosum, which is kind of the birthplace of microglia. You don't see a lot of activity except in those deep brain centers in healthy individuals. So ain't it true? So now it varies day to day who you want to smack, but this is a normal reaction to stress. It results in abnormal regulation of your CB1 function in your brain. It makes you edgy and irritable, and it does make you want to smack somebody. It really does. So when you feel like that, just recognize that's a biomarker within your body of your CB1 system acting up and getting a little bit too involved. Or your husband could just be off that day. So it's time for an Autism Mom video. I promised you an amazing mom story. She wasn't able to fly up here, but she's going to be here, and you're going to love this. Let me just jump out here real quick and get to this video. I don't know where the volume's set on this, so this could be interesting. Do we have a volume out on this? Or do you have a volume out? You're good on that? Okay, great. With any luck?
So thank you very much for taking a little bit of your time.
It's not actually, the video is not projecting.
You're a mom, you've got everything happening in your crazy day to actually talk, but
and the sound is terrible.
Things to other moms and get a chance to kind of explain how.
And I'm really so far disappointed. So we're going to take a little minute for our technical difficulties. So while he's trying to fix my video, let's take a couple of questions. So way in the back, why did you have to be all the way in the back and ask questions? Come on now. Speak up. Okay, don't be late again.
CBD, and I sent him to school. The teacher, at the end of the day, grabbed me.
You have to be, the therapeutic, well, one second, let me stop here for just a second. When THC and cannabidiol are given together, cannabidiol tends to ameliorate the psychotropic effects of THC. So when they're both given at the same time, particularly with a high ratio to cannabidiol, you don't get a lot of those psychotropic effects from THC. So if you use that and you think that's an anti-seizure mechanism, you can get away with higher doses of THC in the presence of that. Any hope? We don't know yet. So go ahead. Anti-seizure medicines. Right. Right.
So as I've been weaning them off, CBD doesn't work good with some of the withdrawals. It doesn't matter how much CBD with a high ratio, that didn't work. So what I did was I started using THC oil, a very high THC oil. That's the only thing that helped my son get through withdrawals.
Interesting.
I think that people need to know that there's much more than just CBD being one thing.
We're going to get to that. No, I agree. And that's a complicated discussion in terms of how do you withdraw from anti-seizure medications and how much of those effects are related to just the medications themselves. Pardon? It doesn't go through the same receptors, but it does change the receptor function. Right. Are you there?
Ready when you are.
Okay. You want to go back to the beginning?
What is different?
Can we go back to the beginning?
Because he was.
This is Libby, by the way, mother of John Paul. Brave enough to show up here, and can we get it back over there, guys?
Here we go.
Well, it kind of moved again, so it's off screen again.
I see that.
Interesting. Back the other way a little bit. It's like hanging pictures.
Thank you very much for taking a little bit of your time. I know how precious it is when you're a mom. You know, you've got everything happening in your crazy day to actually talk. But you wanted to say some things to other moms and get a chance to kind of explain how using CBD, hemp-derived oil, has actually changed your child. So tell me a little bit about how your boy's doing.
Okay, well, the first day we did the CBD and I sent him to school, the teacher at the end of the day grabbed me and said, "What are you doing? What is different?" Because he was focused, he completed work he'd never done before, he was calm, she was absolutely, and it was immediate for my son.
Now, just let's paint a little picture about your boy, okay? He was one of the most hyper, the most self-stimulatory children in my practice. And you're not like, you're in the business. I mean, why don't you tell people what you do, in addition to being a mom?
I'm a speech-language pathologist and have worked with autistic children for about 12 years before I had my own.
God does have a sense of humor, doesn't he? He does.
And he is particularly challenging. If he had been one of my clients, I would have sent him home thinking, God, he wasn't mine. So, yes.
So we went from that, from just kind of a wild man running around nonstop, yes. OCD like crazy.
Yes.
We've done a lot of things that various times, some things have been really helpful, but we couldn't get that stability. He was always very volatile. I mean, one morsel, well, his big downfall is ice cream. And if he gets a hold of ice cream, his skin starts to itch, he picks at it, yes. Things go really bad. But he's been so much more stable. So much better, and to the point if a babysitter has to cancel, I don't lose my mind because I know I can handle it. He's following directions, he's listening to me. It's great. It is wonderful. I feel like I can take him places. And the teachers can work with him. The therapists can work with him. He's actually starting to progress in school because he can be taught now. He is starting to sit down at the table and write letters. Today they showed me he was getting out markers and coloring and choosing different colors. There was definitely thought process by what he was picking and doing. Excellent. So we're thrilled. He's using both hands, left and right, to do things, which blew the babysitter away last night. That's awesome. Yeah, we're really excited about it. Well, I'm happy to have a chance to get you to brag on your kid because you haven't had that many opportunities to really brag on him. So this is some pretty neat stuff. So yeah. I thank you for sharing that with everybody as well. Sure, you're welcome. All right, bye. Bye.
Great mom, huh? So. Pretty brave to show up in my office in your jogging outfit, no makeup, and let me record you and put you out in front of a whole big audience. So that's pretty heroic right there. We'll figure out where we are. I mean, it's still saying we're at the mom video. Isn't that weird? Let's go on down. See if we can catch it. So, regardless of the specific mechanism, and we'll talk some more about possible mechanisms of how that happens, that anecdote itself is pretty powerful stuff. It means something. At least in that one child, in the N of 1, that was an extraordinary outcome. Thanks. Great. Let's see if we can get it to actually play now. I don't know. It doesn't want to run the slideshow. No, so I'm saying it's not running the slideshow. And it's actually frozen. You might want to reboot the whole talk. Okay, technicalities being what they are. So, all right, ready, set, go? Good. Except it is not duplicating here anymore, but that's okay. I'll try and figure it out. Okay? So, quick little talk about essential oils and how they might be working. I know you all have an interest in that. So this was a fascinating article in terms of kind of in the mainstream, but interesting sort of literature. And I'm going to try and get this where I can actually see what I'm talking about since it's not duplicating anymore. Maybe. We might. Good. So Beta caryophyllene is an ingredient in many plants. It has cannabinoid activity. It's very specific for CB2, the anti-inflammatory receptor. Has no apparent CB1 activity whatsoever. It's high in pepper, and with pepper you get the benefit of that other, the piperine compound, which seems to facilitate the entrance of it. So you'll see kind of where I'm headed with this in a moment. So this article says, hey, maybe this one ingredient, which is perhaps as much as 30% of hemp oil, is the most important component of it. We've been doing a lot of talking about cannabidiol, but maybe this ingredient of hemp oil is even more important. And their hypothesis, based on some interesting literature that's been published, is that this is probably better than what Big Pharma is working on in terms of trying to change that. And they said it's going to erase, years of potential work in the pipeline to come up with a better drug than what nature is already providing, which I think is interesting. Here's some more about piperine. That's that ingredient that's in pepper and other plants that seems to have some interesting effects. In this study, cortisone therapy reduced BDNF and resulted in a depression-like model in mice. BDNF, brain-derived neurotrophic factor levels, dropped precipitously. You can see the dark, well, let's go now. It's not moving again. So sorry about that, guys. Let me go and see if we can reconnect to the projectors. Give me one moment here to be, yep, connect to projector. See if we do it. I think we're going to grab it now. We just needed to duplicate it. And we're good. Should work now. Yep. Sorry about that. Excellent. Okay, so this is the slide that I was talking about. So when you provide high doses of corticosteroids, and many of you have been through times with your child where you've been exposed to high doses of steroids, you, at that same time, dramatically reduce BDNF, which is an important brain trophic factor to help the brain to grow and do its things, resulting in some bad things happening. So a dose of 5 to 10 milligrams per kilogram of piperine, the black pepper associated phytochemical, rapidly corrected that, which is interesting. So, and we know that there's altered BDNF RNA transcription in kids with autism. So they're not making as much BDNF to start with. So it's intriguing to see if these phytocompounds can work together to try and normalize those brain trophic factors. And the brain trophic factors are in part why we give stem cells, because certain types of stem cells have trophic factors that we're using essentially as a pharmaceutical implant to affect the brain in certain specific ways. Again, you can see the numbers, and you can see how much lower in the dark box on the left the autism scores for BDNF are compared to the controls on the right. And then right in the middle is ADHD. It's kind of halfway between those two. So this is the influence of piperine on the absorption of curcumin, and it increases the absorption of curcumin, which is an interesting polyphenolic compound with anti-inflammatory properties and some very other interesting sort of dynamics that it has, by 2,000%. Huge. So micro doses can be given to get a pharmaceutical dose. And this is another study on beta-caryophyllene as a dietary cannabinoid, where it was able to dramatically reduce inflammatory reactions with no psychoactivity in mice. Again, can alleviate pain, take away inflammatory reactions in a neuropathic inflammatory model of pain. And they're working on some potential modifications of this molecule, because if you're a pharmaceutical company, you can't get a patent on what nature makes, so you have to add something here to the molecule or take away something there from the molecule, then you have a patentable drug. So this is Big Pharma working on a very important molecule, seeing if they can improve upon it. Seems like a pretty good molecule right now. These are just the domains that are out there, which you don't need to worry about. And this is an interesting product. So this is curcumin 500 with bioperin, and each capsule provides 500 of curcumin and 5 milligrams of bioperin, or piperine. Very interesting combination. But I think what we're going to see with a little bit of push is some improvements in these ratios and some other compounding of this particular molecule, and possibly with some of our other friends. This is lavender, and if you extract lavender with alcohol and water, you get very powerful anti-inflammatory, antioxidant effects that are probably mediated through the cannabinoid pathways. So what if, this is my big what if, cannabinoids, including CBD and beta-caryophyllene, were combined with an absorption agent like piperine and possibly some essential oils? Can we start to get to a cocktail that can really address some of these more complicated, difficult to resolve obsessive-compulsive types of actions and self-stimulatory behaviors? And I would say likely, based on what we're observing in the clinic so far. Now, this is an area that's relatively easy to research. These products are in the nutritional side of FDA regulations, which means that getting IRBs and studies together is much simpler than trying to go after pharmaceuticals. These are plant-derived compounds, so it should be relatively easy to get IRB approval, relatively, to start looking at these because they have wide safety areas with them and some interesting possibilities. So I think I've discovered the meaning of life. You just hang around until you get used to it. So that's where a lot of you have been, right? You're just kind of hanging around trying to get used to what life is throwing you, and it's not always pleasant, so let's see if we can improve on that a little bit. So, interesting article from the group at the Mind Institute saying that plasma cytokine levels are altered very significantly by risperidone, which is an antipsychotic medication, and they proffer in this article that that may be the actual mechanism of therapy in autism, is getting the cytokine, which are pro-inflammatory molecules in the immune system, toned down rather than its big gun antipsychotic effects. So that's kind of intriguing. Here's an interesting article that just came out in 2013. So depression is an inflammatory disease, but where does it come from? It comes from your gut. I mean, it comes from the misregulation of those fatty acid metabolites of the bacterial microbiome that's communicating through the endocannabinoid system in abnormal ways. So selective CB2 activation, so stimulating the CB2 receptor, reduces damage to the CNS in a model for multiple sclerosis. So neuroprotective agents, a whole bunch of the cannabinoids have neuroprotective effects. It's kind of a complicated mixed bag in terms of what dosing of certain compounds and where do we go with that, but it's a very interesting area. This is kind of a complex article, and I throw that kind of slide up there not for you to take notes on it and pictures of it and memorize those pathways, but just to know that there's kind of there's a lot involved in this. So simple regulatory mechanisms are not easily applied, but the only existing cannabinoid that's known as of 2014 that's devoid of CB1 and CB2 activity, but possessing significant anti-inflammatory and neuroprotective properties is cannabidiol. I don't think there's been, the CB2 agents are very anti-inflammatory and neuroprotective as well, and that's the beta-caryophyllene. This is our paper on CB2 activity, and I just wanted to show you the changes between control with the protein content of the receptor in autism-related monocytes. So you can see tremendous amounts of CB2 upregulation, which is the model for pro-inflammatory disorders in the autism monocytes, making it a great target for the things that you want to potentially do with your cannabinoid regulatory pathways. Crosstalk between the gut microbiota and the endocannabinoid system, impact on the gut barrier, and adipose deposition. So adipose deposition is nothing more than a chronic inflammatory disease. Being overweight is being chronically low-grade inflamed. And over a long, long period of time, it's going to take its toll on the body. It's going to take its toll on the endovasculature, the lining of your blood vessels, your joints, your muscles, your brain, and everything else. So as a model for autism, it's a little weird to be talking about all the research on fat-related metabolism in CB1 and CB2, but I think because there's so much of it, and now the people who are really studying where's all the obesity coming from are saying it's really the microbiome. It's what the microbiome is communicating inflammatory-wise to CB1 and CB2, and it's the same model that we see in autism. It's the same process. Even if your kid is skinny, it's the same process. It's just being regulated through slightly different pathways. So low-grade chronic inflammation is exactly what we see with the literature. Kriegsman and other folks, some really good work from Steve Walker looking at the transcription of those type of inflammatory molecules in autism has already been published. Interaction between the gut microbiome and the enteroendocrine system. So a lot of issues related to hormonal regulation within the GI tract, metabolic endotoxemia, so getting those toxins absorbed from the bacteria when they should be kept out by the barrier, and then ultimately interaction with the endocannabinoid pathways. So another article showing endocannabinoid system as an emerging key and player in inflammation for sure. Those are those funny looking fatty acid molecules that actually interact with it, but other rearrangements in nature of that chemistry can still interact with the cannabinoid receptors. Cannabidiol provides long-lasting protection against the deleterious effects of inflammation in a viral model of multiple sclerosis. And you can see where the red arrow is. What you can identify there is after insult to the brain, insult plus cannabidiol is about equal to control. So if you see that little black line on the far side, that's the control. The big gray line is the insult, and then where the red arrow is what the effect of cannabidiol did on that insult to the brain. You can see, again, the TMEV plus CBD. That's, oh, my arrows are showing up. How about that? Only on that one, though. And only part of the time, not all the time. So you can see that those levels as an anti-inflammatory are comparable to the control state. The new face of endocannabinoids and pharmacotherapy, part 2, the role of endocannabinoids in inflammation and cardiovascular disease. So the cardiologists, the people that are interested in diabetes, the people that are interested in obesity, the people that are interested in Parkinson's and Alzheimer's disease, and now us in the autism community all have the same interest, which is how do we re-regulate this endocannabinoid system because it's so powerful it's running the entire show. This is where cannabidiol sits within this particular paradigm that they published as a centerpiece of cardiovascular protection. One of the things that we know about autism, or highly suspect, it's difficult to prove, but based on the kind of information that we see, is that the blood-brain barrier isn't so much of a barrier in autism, and it's allowing more things into the CNS, the central nervous system, than should be there, and as a consequence, the kids become highly sensitive to the things in their ecosystem, what they eat, what they breathe, and those sort of things. It's likely that agents like cannabidiol, possibly combined with those other agents we've been talking about, can help to reseal that endovascular space. And again, that endovascular space is what we feel is resulting in that increased fluid accumulation that I showed in the earlier talks. Microglial activation underlines cerebellar deficits produced by repeated cannabis exposure. So smoking marijuana versus using these highly selective oils that are purified and isolated is a different process. So we're not suggesting that your kid goes out and buys weed at the corner and starts smoking it. By any means, that would be inappropriate. They'll do that on their own as soon as they're able to. The endocannabinoid system mechanisms behind metabolic homeostasis and imbalance. So really, the true stabilizer of your metabolism, including your brain chemistry and your immune system, is this extremely powerful endocannabinoid system, which is highly sensitive to the lipid digestive processes coming in from the gut microbiota, which is why I think that we're really talking about the one thing that ties all of our observations together and makes sense out of it. Bridging immunity and lipid metabolism by gut microbiota, again, ties you back into what's going on with that system. Some cool pictures that I'll wind up putting on the blog so you can kind of look at this and study this over time. Just want you to know that they're coming your way soon. Experimental colitis in mice is attenuated by changes in levels of endocannabinoid metabolites. And here they're talking about inducing selective inhibition of the fatty acid amide hydrolase, which is the enzyme that breaks down that good stuff, AEA. So part of the discussions that will take place with my Italian research colleagues in the next few days, maybe tonight, is can we give these fatty acid compounds as a nutritional supplement and see desirable changes in the gut ecosystem and the gut function of kids with autism? And that's a question that has yet to be answered or studied as far as I know. Nutritional properties of dietary omega-3s and the phospholipids that are associated with them, the more complex the oil and the less purified the oil, which is why things like krill oil, which has a lot of complex phospholipids in it, as well as antioxidants, may be a better blend for our kids than just using the highly purified fish oils. And if you're a manufacturer of fish oils, don't take that as a sign that I'm saying it doesn't work, because I have some kids who do very well with fish oils as a cognitive enhancer. So I want to look at where are these cannabinoid 2 receptors distributed in the body, and this has recently been mapped out. So some very clever people designed a way to actually look at where all the endocannabinoid receptors are. And what you can see is they primarily occur in the liver, the spleen, the peri-aortic lymph nodes, which are draining material from the bowel. They're in the meninges, not so much in the cortex of the brain. And that, again, gets us back to where this whole meningeal inflammation, if it's occurring in autism, may be significant. Your friends may be nuts, but they're rooting for you. So it's okay to have some nutty friends. I count myself as being a little nutty from time to time. I never dress up like this, though, ever. Maybe we should have like a flapper party next year at Autism One. That could be kind of cool. Toward modulation of the endocannabinoid system for treatment of gastrointestinal diseases. FAAH stirs, but not higher, so they want to go like faster, meaning that using that enzyme pathway and blocking that degradatory pathway or enhancing the metabolic activity of that to kind of go the right direction may be an important intervention. Cannabidiol exhibits anxiolytic but not antipsychotic properties evaluated in social interaction. And really, to deal with the antipsychotic properties of hemp-derived oils, you need other cannabinoids and potentially THC, which is going to get us into some regulatory challenges in terms of the state that you live in, whether or not you can use that. So this is a reported parent survey of cannabidiol-enriched cannabis use in pediatric treatment. This is from a California medical school, Stanford. And they saw very significant parental observations of improvement, not the same as a double-blind controlled study, but it's moving things in the right direction. Glucose metabolism, focus on gut microbiota, endocannabinoid system, and beyond. And this is why giving your kid sugar makes them crazy. I've had a hard time trying to explain why sugar causes so much both addictive type of behavior and almost immediate craziness in our children in particular, but ADHD kids as well. I'm like, what is the mechanism for that? It's not merely glucose metabolism, and it happens too fast to be related just to yeast-related metabolism and things like that. It happens like almost instantaneously, doesn't it? So that has to be working through triggering this pathway, the endocannabinoid system pathway, to cause both the addictive type of behavior. And come on, how many of you are addicted to sugar? Let's be honest, okay? Now you know why. You have to start to change that message. So in the next 2 months, I need a little bit of time to pull this together. I hope to have a blog post to help parents to be healthier and to avoid these kind of things that we're all really falling victim to. It's incredibly powerful, and it doesn't take a lot. And I know you all say, I don't really eat that much sugar, and whether or not that's true or not, I don't know, but it doesn't take a lot. It really doesn't take a lot to throw you in the wrong direction, particularly after you're 25 years old. Amen. This is kind of a nice, colorful schematic of the system. It's too complicated to go into in a lecture like this, but I just want you to be aware of the fact that it is being investigated, it's understood, it's extremely complex, and the things that drive it are also complex. But here's our overweight, middle-aged man headed for type 2 diabetes, and ultimately, at the centerpiece of this is altered endocannabinoid tone and resulting inflammation, the same types of things that our kids are showing us as well. CB1 is at the center of that activity. So the endocannabinoid system and gut bugs work together to cause this. And this is, I wanted to get to this, and we're almost out of time, so I'm glad we got here. So this is another steroid therapy research, but this is being done out of Duffy's laboratory at Harvard, looking at electrophysics of the brain and seeing how the brain physics change and result of steroid manipulation, which we know is going to alter BDNF and do some other things that are pretty bad. He did see some improvements in brain function on his particular electrophysics, but with huge complications. So let's go down over here. Cushingoid type of effects. 18 out of 20 kids develop a cushingoid type of a symptom. Mild behavioral disorder, 7 out of 20. Sleep disorder, 2 out of 20. Regression, 2 out of 20. Weight gain, 19 out of 20. Severe behavioral disorder, 3 out of 20, combined with the mild behavior, 7 out of 20, which is half the kids had behavioral disorder that resulted in this. It's hard to think of steroids as a desirable intervention in this kind of environment when we have a much safer product, which is the CBD-rich hemp oil, that can have those kind of anti-inflammatory effects. And not just CBD, but the other products we were talking about, like the beta-carotene, is an important ingredient as well. So cannabidiol exerts anticonvulsant effects in animal models of the temporal lobe and partial seizures. The dose is in the range of 1 mg per kilo, which is extremely costly. However, if, and this is a maybe, I think it would be simple to design some research studies where we add CBD-related type of concentrates, which have other cannabinoids in them, to things like piperine to increase the absorption and possibly keep the cost in line with something that might be much more reasonable for our families. Again, it's time to start thinking about dysbiosis as a disease. So an abnormal gut ecosystem is going to result in a multiplicity of problems, and now there's research all the way up looking at it even in schizophrenia and Alzheimer's disease being tied back to the gut ecosystem. So the gut microbiota, enteroendocrine function and metabolism. Just to give you an idea of another article on endocannabinoids as lipid modulators, the immune system, the possible nexus between cannabinoids and psychoses. It's this dysregulation of the endocannabinoid system that links into that. So glutaminergic tone is regulated by the endocannabinoids, and with that, pretty much out of time, but not out of slides. So I'm just going to show you that there really are a heck of a lot of articles on this. And I know that you're getting all of this as we go through it. But as you can see, it's a lot. So you guys have been awesome. Thank you very much. And I hope you have a better understanding of the system. Thank you.